9.2 with an acronym. The acronym is well, I'm going to need to not put so much space in between those. P, H, A, N, O, M. Phantoms. Phantoms. If you do phantoms on every one of your inference problems, you will get a 4. Alright? It's guaranteed. Unless you, of course, I guess unless you state the wrong parameter or something like that. Or your hypotheses are wrong. But you're gonna squeeze out as many points as possible if you go through this. Because what happens is a lot of times students know what they're doing, but they skip a step. And then they get docked. So, and if you only have 6 free response questions, you need to gather points as much as possible, right? So phantoms. The P is for parameter. So what you need to do is state your parameter of interest, or the parameter of interest. So examples of parameters, right? What would our parameters be? Mu, x bar, p hat, right? Those will be our parameters of interest in this case. And now the next thing we'll do is our hypotheses, right? So H is hypothesis. So state what you need. If you're doing a confidence interval, you're going to talk about what type of confidence interval you're going to use. A stands for assumptions. In other words, check your conditions. So important. So important. N stands for name the test. You must name the test that you are using. And we could say or confidence interval. So again, though we didn't use this when we were doing confidence intervals, do use it now, from now on in the future. I didn't want to introduce it during confidence intervals because we've got this whole hypothesis thing, and that's not a discussion we needed to have until chapter 9 right now. All right, T stands for test statistic. Which is usually in the form of a formula. So this means, hey, show your formula. And it'll make more sense why that's the formula. Why test statistic means formula as we go through this chapter. O is for state the observed value. Observed p-values. So you perform a test, it'll give you a p-value, right? So this is your observed so, in other words, state the p-value. Okay. M is make a decision. And I might need a little more space here. In this case, if we're doing some sort of inference, what decision you're going to make? You're going to either reject or fail to reject the null hypothesis, right? Or if you have a confidence interval, you're going to state, you can make a conclusion based on where if your parameter falls in your confidence interval or not, right? So S is going to be state your conclusion in context, always. And that's it. That is phantoms. So every single time I will do one of these problems, I will follow the phantoms format. So there it is. There's the groundwork for this thing every time. And I need to start working on getting this thing beautiful for you. Quite pretty. Huh? Be specific. So there are other ones. Why not? Why not have a little a day of these real quick? Some other things are sin. It is a sin to not check conditions. What are you checking for? That it's from an SRS? That it's independent? And that the data is normal? All right, those are the things that you check for. And then, yeah, I'm not going to put the other one up there. The other ones are not. They're not. We have other acronyms for them that we've learned for the other ones. So I'm going to change this up and put the acronyms that you've already learned, like SOX, the plan, do, state, conclude. We'll talk about all that. Okay. All right. But that, I like the sin one. Did you need me to put that back? Yeah. It's a sin to not check conditions. So speaking of it being a sin to not check conditions, hey, there are conditions that you need to check in order to carry out a test about a population proportion. So that's what that's what 9.2 is really about. It's about tests about a population proportion. I decided to not capitalize and then capitalize. So if we are going to do this, we need to check some conditions. We need to check, first of all, we need to check S. We need to see, is it from a simple random sample? If yes, continue. And always included in that S is the 10% condition. Does your does your sample represent at least 1/10 of the population, right? And then we need to check for large counts. Your book says large counts, but really we're checking for, hey, is it normal? Let's see. All right, we're checking to see if it's normal. How do we check that? Yeah, you can do that, absolutely. And then, let's see. So, yes, exactly. It's for a proportion, it's NP.
It's less or is greater than or equal.
And then also,
P or 1 minus.
it's n times 1 minus p. Right, that's the one we do to check if the population is large enough, right? To use a normal distribution for a proportion, right? If we're testing a mean, we can just use n greater than or equal to 30, okay? If we were testing a sample mean. For this one, this is what we got to do for a proportion. Okay? So this is the one we got to check. So, let's check out the whole kissing thing. Kissing the quote-unquote right way. So hey, the kissing the right way, right? Remember, there were 124 kissing couples. It's a good thing they're not kissing individuals. Randomly sampled, right? So, I believe then you can say SRS, Chin, right? It was randomly sampled. We're talking about all kissing couples, right? All kissing couples. So, do we think that 124 is, I'm trying to not this time with my brain today. Sorry. 1/10 of all kissing couples? Yeah. Right. Another way to say that is that 1,240 is less than all of our people that kiss. Right? And yeah, that checks out. So we got so this is the S part of our sin all taken care of, right? Is each observation independent? Yeah, it doesn't matter, but yeah, it's true, right? The fact that one couple tilts their head to the right doesn't affect the fact that another couple tilts their head to the right, right? It would be weird. If it did, and you were looking around and being like, hey, they did it that way. We need to do it this way, right? That would be strange. So then we need to check the N part of it, right? So what we need to check is it the case that N times P was greater than or equal to 10, and then N times P minus 1 greater than or equal to 10. in this case, what was P? We determined that I'm gonna have to look at it. Alright, we need to change this to P naught. So first of all, we need to talk about what this P naught is. Alright, so it's the hypothesized proportion. So in this case, we said that we hypothesized that it was greater than 0.5, right? And the reason why we chose that was because, right, if our proportion of people that tilt their head is actually 0.5, then there must not be any preference, right? So in this case, we're checking for our hypothesized value. So we will check for 125 times 0.5. And that checks. Then we will also check for, 124. Okay. And then for this one, we have 124 times, sorry, I'm making a lot of very small errors. I'm sorry. This should be 1 minus P naught. And that's going to check as well. And so there we are. We checked them. And I'm going to go back and actually change this. Sorry, this should be P naught. I apologize. P naught. So I did write this wrong in the notation to P naught. P sub 0. Okay. Okay, so now let's talk about calculating a test statistic. And then the p-value that follows from it. Alright, here we go. So, a test statistic. Is going to be I don't know why we have a statistic minus parameter all divided by the standard deviation of the statistic. This is always what it will be for everything when you're and this will cause us to create a formula. All right. Let's do our first inference problem. Here we go. Let's do it Phantom style. So let's actually perform inference on her kissing the right way. So it says calculate the test statistic and find the p-value. We're going to actually go through this, all right? So what is our parameter? Our parameter is the proportion of couples who prefer to tilt their head to the right. All right, we'd like to know what that proportion is. All right, H. Our hypothesis. We said that H naught is 0.50, right? Which means that our alternative hypothesis H naught is that P is equal to 0.50, right? And our alternative hypothesis is that the true proportion is actually greater than 0.5. So we're trying to find evidence against the statement that the true proportion is actually 0.5. All right. A, assumptions. We already checked conditions, right? On the last page. This was named the test. So we're going to use a one proportion So we're going to perform a one proportion and now T, let's get down to it. So now we can answer our test statistic. So I said our test statistic is our statistic minus parameter divided by the standard deviation of the statistic, right? In this case, our test statistic is a z-value, since we're doing a z-test. And we're going to use a normal distribution. So we're going to get a standardized value, z value, and we're going to use our normal distribution in order to calculate a probability. So that's our plan. So that is going to be, and remember, we had a p hat value of 83. Remember, so we found, or the person observed that 83 out of the 124 people tilted their head to the right, and that was approximately I'm pretty sure this is approximately 0.669. That's our P. So, in this case, we're going to do, I'm going to write what the actual formula we're going to use. So this is going to be P hat minus P all divided by our standard deviation of our statistic. We've already checked our conditions to use the standard deviation, right? Because they're the same as the conditions that we would use to perform the test. And that is going to be P times 1 minus P all divided by n. Alright, so we'll put that into, we'll actually put our values that we have in there. So our P value 0.669 minus 0.5 all divided by the square root of 0.5 times 1 minus 0.5 all divided by 124. Alright. So that is our test statistic. Beautiful. Alright. So let's go ahead and obtain a p-value. And I'm going to show you how to do this with our calculator entirely. But right now, I'm going to need my... Alright, 3.764. And then I'll show you how to get all this stuff from your calculator like all at once. These calculators are amazing. You said approximately 3.764. Wow. If you have your z-table handy, check it out. 3 is a very extreme value. Also negative 3. Actually, 2 is an extreme value, as well as negative 2, if you look at it. For values that small and that large, your probabilities are quite small for values above 2, right? And quite small also for values below 2. Right? Mine doesn't have a z-table, so I can't look at it. Wait a second. But let's go ahead and draw that. So the next thing is O, because we're going to obtain we're going to obtain a p-value. So let's draw a picture of that. For a value p of 0.5, we're looking at the probability that x is greater than or equal to 0.669, right? Which is going to be the same thing as the probability that Z is greater than or equal to 3.764. So it turns out that that's going to be way over here, right? So this is my shaded area that we're looking at. I guess I could make it a little larger, but that's a very, very small amount, right? So let's go ahead and get an actual value. I'm going to go through this all in our handy dandy calculator. So let's go ahead and do a one sample z-test on our calculator. And so I am going to go ahead and I can just do this with my calculator. So I'll hit menu and then go to statistics. We're going to look at stat test. We're going to do a one proportion z-test. Don't die. There we go. P naught, you said was 0.5. Successes, we had 83. N was 124. And in this case, we're saying that our proportion is greater than 20. Our p-value is 0.000081.
What does that value mean?
Huh?
What does that value mean?
So that is the probability.
Something here, right?
Yeah. So given the proportion that we found, that's the probability that the true proportion is 0.5. So we observed and got a p-value. This is the probability, given that p-value, that the actual p-value is 0.5, which means that we have strong evidence to reject the null hypothesis. Hold on.
I haven't been able to do it.
So that discussion brings us to M. Make a decision, right? So make a decision. Make a decisions? No, we won't make any decisions. Make a decision. We are going to reject, right? So with a p-value so low, we are going to go ahead and reject the null hypothesis. So we're going to reject H naught, our null hypothesis. This I cannot spell today. Decision. Sorry. So we're going to reject the null hypothesis. So there is strong evidence
Actually doing words there?
that the true proportion Okay. 2 the right is bigger. Because me. 2 let's use PM. Zero point 0 0 0 0